We're almost done with the wheel. Let's consider what we have. We have a wheel which is laterally true, radially true. The wheel is dished. I have the tension on the drive side set to the right level, and I have consistency, and I have relative consistency of the spokes on the non-drive side. So those are all things that I want to have come together when the wheel is finished, and they did. There's one thing I have to do though, and that is called elimination of spoke windup. Now, spoke windup comes about if you have a spoke, let's say this one here on the drive side, which has a lot of tension on it, and I want to tighten the spoke by turning the nipple. At some point, the whole nipple and spoke will turn together, and tensioning depends on the spoke remaining straight and the nipple turning on the threads on the spoke. If the whole thing turns together, that's called torsional windup. And when you go and you ride the bike for the first time, you'll hear a pinging, and that will be the torsional windup coming out. It doesn't hurt anything, but it can be a little disconcerting. And if you're building a wheel for somebody else, you don't want that to happen. So the last thing I want to show you is how you get the torsional windup out of the spokes. Here's how it's done. This is a board I have which has been used thousands of times, but there's a hole here in the board, and I'm going to start with the non-drive side flange. I'm going to put that down inside where the that hole is, and then I'm going to find opposite sides of the wheel where spokes go to the down flange, and I'm going to just lean on the wheel like this. I'm going to go all the way around, and sometimes you'll hear a little tone, you'll hear a little creaking, cracking, and that is the release of tension from torsional windup, if there is any. Maybe there's not, but we're giving the spokes an opportunity to unwind if they have wound up. And now I do the same thing on the other side. I'm not feeling much, so maybe it didn't happen in this wheel too much, and that's fine. So we go all the way around a couple of times. Now this should not knock the wheel out of true at all, but it might a tiny bit. So our last step is going to be to put the wheel back in the truing stand and make it perfect. Well, it turns out that there's not really anything to do, because we give the wheel a spin. We see that there's absolutely no error either sideways or up and down. That, my friends, is a good wheel. And they don't always come out this nicely, but most of the time they will. So here's our wheel, came out quite well. And some of you may be wondering, well, that's great, but what if I have fewer spokes? What if I have bladed spokes? What if it's a disc brake wheel? There are some small differences in those cases, and I will refer you in a couple of minutes to where you can learn more about other kinds of wheels. But generally speaking, the process is the same. So if you are consistent in your application of spoke tension and you have a good starting point, and you wait to do the tensioning at the right moment and things like that, and you do things in the correct order at the right time, you're going to get a good wheel every single time.